Welcome to the Data Visualization with Python course. The Data Visualization with Python course is ideal for professionals with knowledge of Python programming language who aspire to become data analysts or data scientists. In this course, you'll learn how to create meaningful, effective, and aesthetically pleasing data visuals and plots in Python using Matplotlib. You'll explore advanced visualization tools that provide various advanced features and capabilities. In addition, you'll identify different web-based dashboarding tools available in Python. In the final project, you'll demonstrate and apply your newly developed skills for creating data visualizations and dashboards using Python library. The 5 modules in this course comprehensively cover the concepts related to these areas. In Module 1, you'll learn about data visualization and best practices for creating plots and visuals. You will discover the history and architecture of Matplotlib. Furthermore, you'll learn about basic plotting with Matplotlib and explore the dataset on Canadian immigration, which you'll use during the course. Lastly, you will analyze data in a data frame and generate line plots using Matplotlib. In Module 2, you will create a diverse range of plots using Matplotlib and the Data Visualization Library. This module will teach you about area plots, histograms, bar charts, pie charts, box plots, and scatter plots. You'll also explore the process of creating these visualization tools using Matplotlib. In Module 3, you'll learn about waffle charts and word cloud. You will create regression plots using Seabor, a new visualization library in Python. In addition, you'll learn about Folium, a data visualization library that visualizes geospatial data. Furthermore, you'll explore the process of creating maps using Folium and superimposing them with markers to make them interesting. Finally, you'll learn how to create a Choropleth map using Folium. In Module 4, you'll explore the benefits of dashboards and identify the different web-based dashboarding tools in Python. You will learn about Plotly and discover how to use Plotly graph objects and Plotly Express to create charts. You will gain insight into Dash, an open-source user interface Python library used for building web applications. Finally, Module 5's primary focus is helping you complete your final lab assignment. The objective is to analyze automobile sales data covering periods of recession and non-recession. After completing this course, you can use different visualization libraries in Python, namely Matplotlib, Seabor, and Folium, to create expressive visual representations of your data for different purposes. You'll also be able to use basic and advanced visualization tools and identify different web-based dashboarding tools. There is a lot to cover here. To get the most from this course, make sure to view every video, review your knowledge with each quiz, and complete all the hands-on labs. If you have any trouble with the course material, please don't hesitate to contact us in the discussion forum. Thank you for being part of our course. We look forward to sharing this valuable knowledge with you. Hello, and welcome to Overview of Data Visualization. After watching this video, you'll be able to explain what data visualization is and why it's important, describe the uses for data visualization, explore the best practices for data visualization. Data visualization is the graphical representation of data and information. It involves the process of creating visual representations of data. Data visualization can take many different forms, from basic charts and graphs to more complex interactive dashboards, maps, and infographics. Basic charts and graphs are the simplest form of data visualization to represent numerical data. Interactive dashboards and maps are more complex forms of visualization to provide real-time information. We need data visualization for several reasons. Data visualization helps us to easily understand complex data sets that might be difficult to comprehend in their raw form. It can highlight patterns, trends, and relationships that might not be immediately apparent from looking at the data. Visualization enables us to communicate insights and findings to stakeholders in a more compelling and understandable way. It allows us to tell a story with data, making it easier for stakeholders to understand and act on the information presented. Visualization helps us identify trends and data patterns that might otherwise be difficult to see. We can gain new insights and make informed decisions by examining data over time or across different dimensions. Presenting data in a more easily understood and interpreted way enables us to identify opportunities, spot potential problems, and make more informed choices. Let's explore how data visualization can help us understand data. The New York Times, a well-known news publication, has used data visualization to help people understand the impact of the COVID-19 pandemic in the United States. The number of daily new reported cases and the number of deaths are shown through a line graph, and the vaccinated population percentage is displayed using a bar graph. Airbnb uses smart pricing framework to assist hosts in determining the best possible prices for their listings, thereby increasing their profits. Using a bar graph, the chart displays the lead time distribution aggregated to a market level. Spotify uses Spotify Pie, a unique data visualization tool that enables users to create customized pie charts based on their listening habits on Spotify. The chart displays the distribution of different genres, artists, and tracks the user has listened to. What you see here is a Choropleth map on Netflix's Insight Tool dashboard with other visualizations like line graphs and bar plots. These dynamic dashboards help them gain a deeper understanding of operations, identify areas for improvement, and quickly address any issues. Data visualization is an essential tool for anyone dealing with data. Companies can gain insights into market trends, financial performance, and customer behavior. Healthcare professionals can identify patterns in patient data and develop targeted treatment plans. Visualization helps analyze student performance and inform instructional decisions, leading to better academic outcomes. Visualization helps governments make informed decisions and communicate data to the public. Visualization helps scientists and researchers analyze complex data, develop new insights, and share findings effectively. Visualization helps workers in the entertainment industry determine ratings and ultimately signals to the creators what the audience wants. Although data visualization has become an essential tool, not all visualizations are created equal. To create effective visualizations, it's important to follow best practices that can help ensure that the data is accurately represented and the message is clearly communicated. One key best practice is choosing the appropriate visualization type for the presented data. Different types of data require different visualization techniques. Choose the right one to communicate the data effectively. Keep the visualization simple and easy to read. A line chart shows trends over time, while a bar chart is ideal for comparing values. To ensure that the data is accurately represented, it's also important to label the axes clearly and provide context for the data being presented. Include a clear title summarizing the main message and a legend explaining the meaning of any symbols or colors used. Including unnecessary graphics or information can confuse the audience and distract them from the main message. Keep visualization focused on the main point and use only the necessary data and labels. Lastly, it's important to consider the audience when creating the visualization. Who will view the visualization, and what do they need to know? The visualization should be tailored to their needs and understanding. What do you think about this plot? Or this pie chart? What is the data trying to convey? In these charts, there are a lot of variables and the information is more difficult to understand. This is an example of bad data visualization. This chart represents a team's board. The stacked bars depict the percentage of the work assigned to the individual users and their work progress. Colors are distinguishable and consistent. The legend shows the individual colors' meanings. The chart provides more clarity with the values and percentages on top of each bar. Dark Horse Analytics is a company that was created out of a research lab at the University of Alberta in 2008. The company has done fascinating work on data visualization. Dark Horse Analytics specializes in quantitative consulting in several areas, including data visualization and geospatial analysis. Their approach when creating a visual revolves around the idea that less is more effective, more attractive, and more impactful. By following these best practices, data visualizations can become a powerful tool. Check out the Dark Horse Analytics website for examples of good and bad plots. In this video, you learned that data visualization is the process of presenting data in a visual format, such as charts, graphs, and maps, to help people understand and analyze data easily. Data visualization has diverse use cases, such as business, science, healthcare, and finance. It's important to follow best practices, such as selecting appropriate visualizations for the data being presented, choosing colors and fonts that are easy to read and interpret, and minimizing clutter. Welcome to Types of Plots. After watching this video, you'll be able to explore different types of plots available for visualizing data. Identify the characteristics and appropriate use cases for each type of plot. As we know, data visualization represents data using visual formats like graphs, charts, and maps. It effectively communicates information, trends, and insights concisely. It also uncovers patterns, identifies trends, and simplifies complex information for easy understanding. Let's now explore the different types of plots. Some of these include line plot, bar plot, scatter plot, box plot, histogram. A line plot, also known as a line chart, displays data as a series of data points connected by straight lines. Line plots display trends, such as stock market fluctuations or temperature changes over time. They compare data sets with a continuous independent variable, like age or time. Line plots illustrate cause and effect relationships, such as sales revenue changes based on marketing budget. They also visualize continuous data, like height measurements over time. Line plots can be misleading if the scales on the axes are not carefully chosen to reflect the data accurately. The line plot shows a downfall in immigration trends in 1998. However, if you will correct the scale on the y-axis to start with 0, as in this plot, you'll see that the actual trend is not that alarming. Let's now explore the next plot. A bar plot, also known as a bar chart, displays data using rectangular bars where the height or length of the bars represents the magnitude of the data. The bars can be oriented either vertically or horizontally. A vertically oriented bar chart is often referred to as a vertical bar chart or a column chart. If you're looking for an effective way to compare data, bar plots are ideal for comparing different categories or groups. They excel with discrete data, like comparing sales revenue by product. They show how different categories contribute to the whole, and rankings, such as sales percentage or budget allocation. Bar plots can visualize data that you can easily rank, like displaying the best-selling books in the market. Their simplicity and interpretability make them favored for data visualization. Inaccurate bar choices or axis scales can lead to misleading plots. In this bar plot, the y-axis, starting at 6, makes the difference between the values in 1995 and 1998 seem larger than it actually is. However, when the y-axis starts at 0, the plot accurately represents the data without misleading the viewer. Now let's go through the next plot. A scatter plot is a type of plot that presents values for two variables for a set of data using Cartesian coordinates. The data points are displayed as a collection of points where one variable's value determines the position on the horizontal axis and the other variable's value determines the position on the vertical axis. When can you use a scatter plot? Let's explore some options. You can use it for examining the relationship between two continuous variables like temperature and energy consumption, investigating patterns or trends in data, such as house prices versus size, detecting outliers or unusual observations, such as outliers in test scores or abnormal stock behavior, visualizing data with many observations to identify clusters or groups, exploring complex data. Outliers significantly impact interpretation, requiring consideration of their inclusion or exclusion. On the screen, the data is plotted with and without outliers. With outliers, it shows two clusters, but removing outliers makes the remaining data more visible. Proper outlier handling enhances accuracy and meaningful insights in scatter plots. Let us learn about the box plot. A box plot, also known as a box and whisker plot, is a type of plot that displays the distribution of a data set along with key statistical measures. It consists of a box representing the interquartile range, IQR, a line inside the box representing the median, and lines, whiskers, extending from the box to indicate the range of the data, excluding outliers. Outliers may be represented as individual data points beyond the whiskers. Let's look at some scenarios where box plots come in handy. While comparing the distribution of a continuous variable across different categories or groups, for example, employees' salaries across departments, examining spread and skewness of dataset, visualizing quartiles and outliers, identifying and analyzing potential outliers within a dataset, visualizing summary statistics, median, quartiles, range, in a concise and informative manner, comparing distributions of multiple variables in datasets side by side. Remember, box plots provide valuable information about outliers, such as their presence and extent. Ignoring or mishandling outliers can distort the interpretation of the data and mask important insights, same as with scatter plots. The last plot we're going to learn about is the histogram. A histogram is a graphical representation of the distribution of a dataset, showing the frequency or relative frequency of values within specific intervals. It consists of bars where the height represents the data count in each interval. Histograms offer valuable insights into data distribution, outliers, skewness, and variability. They visually depict the shape of the data, whether it's symmetric, skewed, or bimodal. Skewness can be assessed by examining the histogram's shape. Histograms also showcase data variability, allowing you to observe concentrations, gaps, and clusters that reveal patterns or subgroups. Apart from issues with scale and inadequate labeling, be careful while choosing the bins to create a histogram. We have generated a random data set and created 3 histograms with 3 different binning options. Too few bins, 5, represented in green color, an optimal number of bins, 20, represented in blue, and too many bins, 50, the yellow one. By comparing these histograms, you can observe how the choice of binning affects the representation of the data distribution and results in a misleading representation of the data. Selecting too few or too many bins can oversimplify or overcomplicate the distribution, respectively. In this video, you learned that there are various types of plots commonly used in data visualization. Line plots capture trends and changes over time, allowing us to see patterns and fluctuations. Bar plots compare categories or groups, providing a visual comparison of their values. Scatter plots explore relationships between variables, helping us identify correlations or trends. Box plots display the distribution of data, showcasing the median, quartiles, and outliers. Histograms illustrate the distribution of data within specific intervals, allowing us to understand its shape and concentration. Welcome to Plot Libraries. After watching this video, you'll be able to explore some popular plot libraries for data visualization. Identify the features of plot libraries in Python. Data visualization is a vital tool for gaining insights and effectively communicating complex information. In the world of data visualization, there are several plot libraries in Python that provide unique features and capabilities. Some of the popular libraries are Matplotlib, Pandas, Seabor, Folium, Plotly, and PyWaffle. Each plot library has its own strengths and use cases. By harnessing the power of these plot libraries, you can unlock insights from your data and effectively communicate your findings. Let's start with Matplotlib. It's a general-purpose plotting library that provides a wide variety of plots and customization options. It integrates well with other libraries and frameworks such as NumPy, Pandas, Seabor, and Plotly. This interoperability allows you to combine the strengths of different libraries and create sophisticated and interactive visualizations. Let's explore some of Matplotlib's features now. You can create line plots, scatter plots, bar charts, histograms, pie charts, box plots, and heat maps, to name a few. Matplotlib also allows you to customize colors, line styles, marker styles, axis labels, titles, legends, and so on. Matplotlib's versatility, customization options, integration capabilities, and community support make it a powerful and reliable choice for data visualization tasks in Python. The next plot library is Pandas. Users primarily employ it for data manipulation, but it also offers plotting capabilities. Pandas plotting functions are built on top of Matplotlib, which means you can leverage the power and versatility of Matplotlib by combining it with Pandas' data manipulation capabilities. Let's now check for some of its features. It integrates seamlessly with Pandas' data structures, making it easy to create line plots, scatter plots, bar charts, histograms, and pie charts directly from your data frames. Pandas' visualization capabilities are well suited for exploratory data analysis. Let's explore the third plot library. Like Pandas, Seabor is also built upon the functionality of Matplotlib. It's a great choice for specialized statistical visualizations. It provides stylish and specialized plot types such as categorical plots, count plots, heat maps, violin plots, scatter plots, bar plots, and many more. Now, let's dive into the features of Seabor. Seabor comes with various color palettes and styles to customize and enhance the aesthetics of the plot. It offers functions to combine multiple plots into grid layouts, which can be useful for comparing multiple variables or subgroups. Its integration with Pandas allows it to plot data directly from Pandas data frames or series. Seabor's combination of statistical visualizations, default aesthetics, integration with Pandas, ease of use, and built-in themes make it a popular choice among data scientists and analysts for exploring and communicating insights from data. The next plot library we're going to learn about is Folium. When it comes to geospatial data visualization, Folium is an excellent library. It allows you to create interactive and customizable maps. Whether it's Choropleth Maps, point maps, or heat maps, Folium provides the tools to visually represent your geospatial data. Here is a key feature of Folium. Folium seamlessly integrates with popular data analysis libraries in Python, such as Pandas and NumPy. It's a popular choice for geospatial data visualization and analysis in Python. Let's now explore the fifth plot library. If you want to present your data in an interactive way, Plotly is a great choice to explore. It offers highly interactive plots and dashboards. With Plotly, you can create line plots, scatter plots, bar charts, pie charts, 3D plots, and Choropleth maps, to name a few. Here are some of the key features of Plotly. Its Plotly Dash framework allows you to build interactive dashboards with rich visualizations and controls. Since Plotly is web-based, it enables the rendering and viewing of plots in web browsers. This makes it convenient for sharing visualizations online, embedding them in web applications or dashboards, and collaborating with others. The last plot library we're going to explore is PyWaffle. If you want to visualize categorical data using waffle charts, PyWaffle is a simple yet effective library. With PyWaffle, you can create waffle charts, square pie charts, donut charts, and many more types of plots by providing a unique way to represent proportions. In this video, you learned that Matplotlib is a plotting library that offers a wide range of plotting capabilities. Pandas is a plotting library that provides integrated plotting functionalities for data analysis. Seabor is a specialized library for statistical visualizations, offering attractive default aesthetics and color palettes. Folium is a Python library that allows you to create interactive and customizable maps. Plotly is an interactive and dynamic library for data visualization that supports a wide range of plot types and interactive features. PyWaffle enables you to visualize proportional representation using squares or rectangles. Welcome to Introduction to Matplotlib. After watching this video, you'll be able to explain what Matplotlib is and why it was created. Describe the uses for Matplotlib. Matplotlib is one of the most widely used data visualization libraries in Python. It was created by John Hunter, who was an American neurobiologist. John Hunter was part of a research team analyzing electrocorticography, ECOG signals, and used proprietary software for this task. However, the team had only one license and was taking turns using it. So, to overcome this limitation, John Hunter set out to replace the proprietary software with a MATLAB-based version that could be utilized by him and his teammates and extended by multiple investigators. As a result, Matplotlib was initially developed as an EEG and ECOG visualization tool, and just like MATLAB, Matplotlib was equipped with a scripting interface for quick and easy generation of graphics represented by the plot. As for Matplotlib's architecture, it's composed of three main layers. The back-end layer, the artist layer, where much of the heavy lifting happens, is the appropriate programming paradigm when writing a web application server, a UI application, or a script to be shared with other developers. The scripting layer is the appropriate layer for everyday purposes. It's considered a lighter scripting interface to simplify common tasks and for quick and easy generation of graphics and plots. The back-end layer has three built-in abstract interface classes. Figure Canvas defines and encompasses the area on which the figure is drawn. Renderer, an instance of the renderer class, knows how to draw on Figure Canvas. The event handles user inputs such as keyboard strokes and mouse clicks. The artist is the object that knows how to take the renderer and put ink on the canvas. Everything you see in a Matplotlib figure is an artist instance. The title, the lines, the tick labels, the images, and so on all correspond to an individual artist. There are two types of artist objects: primitive, line to D, rectangle, circle, and text; composite, axis, tick, axes, and figure. The top-level Matplotlib object that contains and manages all the elements in each graphic is the figure artist. The most important composite artist is the axis because it's where most of the Matplotlib API plotting methods are defined, including methods to create and manipulate the ticks, the axis lines, the grid, and the plot background. Each composite artist may contain other composite artists as well as primitive artists. So, a figure artist can have an axis artist, a rectangle, and a text artist. The artist layer is syntactically heavy. Programmers work directly with the back-end and artist layers as they offer greater convenience while integrating Matplotlib with application servers. When it comes to the daily tasks of scientists involving data visualization or exploratory interactions, the scripting layer, known as PyPlot, works better. Matplotlib's scripting layer is the Matplotlib .pyplot interface, which automatically defines a canvas and a figure artist instance and connects them. So let's generate a histogram of 10,000 random numbers with a scripting layer. So first we import the pyplot interface, and you can see all the methods associated with creating the histogram and other art objects and manipulating them, whether the hist method or showing the figure is part of the pyplot interface. Notice the use of NumPy's random module with random.randn for creating random floats from the pyplot hist method is called. Hist creates a sequence of rectangle artists for each histogram bar and adds them to the axes container. To the hist function, we have passed the variable x containing an array of 10,000 random numbers and 100, which means creating 100 bins. The result is a histogram. It's simple to work in the scripting layer. The anatomy of a plot refers to the different components and elements that make up a visual representation of data. There's a reference on the official website of Matplotlib titled Anatomy of Figure. This image provides a complete guide to understanding what a plot may include based on your requirements. The main component is the window or canvas containing the plot or subplots. Matplotlib's figure is a canvas. An axis represents an individual plot within a figure. You must first create two axis parts to make two plots on one figure. The axis provides scales and tick marks for plotting the data. The actual data being plotted is represented as points or markers on the plot. Like the axis, a good plot must have a title to provide a summary or explanation of the plot. Likewise, labels describe data being plotted on each axis. You may like to include a legend to explain the meaning of different elements or data series in a plot, a grid to help visually align data points and aid in reading values from the plot, and annotations to provide supplemental information or explanations about specific data points or regions in the plot. You can choose symbols for individual data point, colors, and styles. This link will take you to a chapter written by the creators of Matplotlib. So if you're interested in learning more about the history of Matplotlib and its architecture, then this is a recommended reading. In this video, you learned that Matplotlib is one of the most widely used data visualization libraries in Python. Matplotlib was initially developed as an EEG/ECOG visualization tool. Matplotlib's architecture is composed of three main layers: the backend layer, the artist layer, and the scripting layer. The anatomy of a plot refers to the different components and elements that make up a visual representation of data. Welcome to Basic Plotting with Matplotlib. After watching this video, you'll be able to explore how to use Matplotlib to create plots by employing Jupyter Notebook, create conventional visualization tools using the plot function. Matplotlib is a well-established data visualization library that can be integrated in different environments such as Python scripts, Python and IPython shells, web application servers, and in graphical user interface toolkits. The Jupyter Notebook is also one of them. The Jupyter Notebook is an open-source web application that allows you to create and share documents that contain live code, visualizations, and some explanatory text as well. Jupyter has some specialized support for Matplotlib, so if you start a Jupyter Notebook, all you have to do is import Matplotlib and you're ready to go. We will now learn how to create almost all of the visualization tools using the scripting interface. As we proceed in the course, you will appreciate the power of this interface when you find out that you can literally create almost all of the conventional visualization tools such as histograms, bar charts, box plots, and many others using one function only, the plot function. Let's start with an example. Let's first import the scripting interface as PLT, and let's plot a circular mark at the position 5, 5. Notice how the plot was generated within the browser and not in a separate window. If the plot gets generated in the new pop-up window, then you can enforce generating plots into the browser using what's called the magic function, %, matplotlib, and you pass in inline as the backend. Matplotlib has a number of different backends available. One limitation of this backend is that you cannot modify a figure once it's rendered. So after rendering the figure, there is no way for us to add, for example, a figure title or labels to its axis. We will need to generate a new plot and add a title and the axis labels before calling the show function. A backend that overcomes this limitation is the Notebook backend. With the Notebook backend in place, if a PLT function is called, It applies them to the active figure if it exists. If a figure does not exist, it renders a new figure. So when we call the plt.plot function to plot a circular mark at position 5, 5, the backend checks if an active figure exists. Since no active figure exists, it generates a figure and adds a circular mark to position 5, 5. And what is beautiful about this backend is that now we can easily add a title or labels to the axes after the plot was rendered without the need of regenerating the figure. Finally, another thing that is great about Matplotlib is that Pandas also has a built-in implementation of it. Therefore, plotting in Pandas is as simple as calling the plot function on a given Pandas series or Pandas data frame. So, say we have a data frame of the number of immigrants to Canada from India and China for the years 1980 to 1996, and we're interested in generating a line plot of this data. All we have to do is call the plot the function on this data frame, which we have called India_China_DF, and pass in kind equals line. And there you have it, a line plot of the data in the data frame. Plotting a histogram of the data is not any different. So, say we would like to plot a histogram of the India column in our data frame. All we have to do is call the plot function on that column and pass in kind as hist for histogram. And there you have it, a histogram of the number of Indian immigrants to Canada from 1980 to 1996. In this video, you learned that Matplotlib is a well-established data visualization library that can be integrated in different environments. Jupyter Notebook is an open-source web application that allows you to create and share documents. Matplotlib has a number of different backends available. You can easily include the label and title to your plot with PLT. Hello, and welcome to Dataset on Immigration to Canada. After watching this video, you'll be able to understand the dataset to be used in this course for data visualization, import data with Pandas as a data frame in your program, process data to make it suitable for plotting. We will use the Population Division of the United Nations compiled immigration data pertaining to 45 countries, where for each country, data corresponding to the total number of immigrants from all world countries are reported, in addition to other metadata pertaining to the immigrants' countries of origin. In this course, we'll focus on Canada and work primarily with the dataset involving immigration to the Great White North. Here is a snapshot of the UN data on immigration to Canada in the form of an Excel file. The first 20 rows contain textual data about the UN department and other information. Row 21 contains the labels of the columns. Following that, each row represents a country along with metadata about the country, such as the continent it resides in, what region it belongs to, and whether the region is developing or developed. Then we have the total number of immigrants from that country for the years 1980 all the way to 2013. Throughout this course, we will be using Pandas for any analysis of the data before creating visualization tools. So in order to start creating different types of plots of the data, whether for exploratory analysis or for presentation, we will need to import the data into a Pandas data frame. To do that, we will need to import the Pandas library as well as the OpenPixel library, which is required to extract data from Excel spreadsheets files. Then we will call the Pandas function readExcel to read the data into a Pandas data frame. Notice how we're skipping the first 20 rows to read only the data corresponding to each country. If you want to confirm that you have imported your data correctly, you can always use the head function to display the first 5 rows in the data frame. Now, let's process the data frame so that the country name becomes the index of each row. This should make querying specific countries easier. Also, let's add an extra column which represents the total immigration for each country from 1980 to 2013. So, for Afghanistan, it's 58,639, and for Albania, it's 15,699, and so on. Now, let's name our data frame df_Canada. In this video, you learned that the Population Division of the United Nations compiled immigration data pertaining to 45 countries. The UN data on immigration to Canada shows data related to the number of people who migrated. In order to start creating different types of plots of the data, you will need to import the data into a Pandas data frame. Welcome to Line Plots. After watching this video, you'll be able to describe line plot and its function, determine when to use a line plot, create a line plot from data in the dataset. So, what is a line plot? As its name suggests, it's a plot that displays information as a series of data points connected by straight lines. It is one of the most basic types of charts and is common in many fields, not just data science. Let's identify when to use a line plot. Line plots are useful for visualizing trends and changes over time, making them a popular choice for time series data, such as changes in stock prices, website traffic, or temperature fluctuations. You can also use a line plot to show relationships between two variables. They can also be used to compare multiple data series on one chart. Line plots can also effectively highlight sudden changes or anomalies in data. As an example, from our data set, we can generate a line plot to see the trend of immigrants from Haiti to Canada. Based on this line plot, we see that there is a spike of immigration from Haiti to Canada in 2010. We can then research for justifications of obvious anomalies or changes. From a quick Google search for major events in Haiti in 2010, one would easily learn about the tragic earthquake that took place in 2010. Therefore, this influx of immigration to Canada was mainly due to that tragic earthquake. Now, how can we generate this line plot? As we briefly mentioned in an earlier video, with Matplotlib, all we have to do is call the plot function on the Pandas data frame or series containing the data of interest. Before we go over each code to do that, let's do a quick recap of our data set. Each row represents a country and contains data corresponding to the status of the country in terms of where it is located geographically and whether it is developing or developed. Each row contains numerical figures of annual immigration from that country to Canada from 1980 to 2013. Now, let's process the data frame so that the country name becomes the index of each row. This should make querying specific countries easier. Also, let's add an extra column which represents the total immigration for each country from 1980 to 2013. So, for Afghanistan, it's 58,639. For Albania, it's 15,699, and so on. Now, let's name our data frame df_Canada. So now that we know how our data is stored in the data frame df_Canada, let's generate the line plot corresponding to immigration from Haiti. First, we import Matplotlib as MPL and its scripting interface as PLT. Then we call the plot function on the row corresponding to Haiti, and we specify kind equals line to generate a line plot. Then to complete the figure, we give it a title and label its axis. Finally, we then call the show function to display the figure. Note that this is the code to generate the line plot using the magic function %matplotlib with the inline backend. There you have it, a line plot that depicts immigration from Haiti to Canada from 1980 to 2013. In this video, you learned that a line plot is a plot in the form of a series of data points connected by straight line segments. Line plot is one of the most basic types of chart and is common in many fields. You can generate a line plot by assigning line to kind parameter in the plot function. Welcome to area plots. After watching this video, you'll be able to describe what is an area plot, explain how to create an area plot using Matplotlib. So, what is an area plot? An area plot, also known as an area chart or graph, displays the magnitude and proportion of multiple variables over a continuous axis, typically representing time or another ordered dimension. It's similar to a line plot, but with the area below the line filled with color to emphasize the cumulative magnitude of the variables. This kind of graph is commonly used when trying to compare two or more quantities. Let's learn how to generate an area plot with Matplotlib. Before we go over the code on how to generate an area plot, let's do a quick recap of our dataset. Recall that each row represents a country and contains metadata about the country, such as its geographic location and its development status. Each row also contains numerical data of annual immigration from that country to Canada from 1980 to 2013. Now let's process the data frame so that the country name becomes the index of each row. This should make retrieving rows pertaining to specific countries a lot easier. Also, let's add an extra column that represents the cumulative sum of annual immigration from each country from 1980 to 2013. So, for Afghanistan, it's 58,639 total. And for Albania, it's 15,699, and so on. And let's name our data frame df_Canada. So now that we know how we have stored our data in the data frame df_Canada, let's try to generate area plots for the countries with the highest immigration to Canada. We can try to find these countries by sorting our data frame in descending order of cumulative total immigration from 1980 to 2013. We use the sort_values function to sort our data frame in descending order. And here is the result. It turns out that India, followed by China, then the United Kingdom, the Philippines, and Pakistan are the top 5 countries with the highest immigration to Canada. So, can we now go ahead and generate the area plots using the first 5 rows of this data frame? Not quite yet. First, we need to create a new data frame of these 5 countries only and exclude the total column. More importantly, to generate the area plots for these countries, we should plot the years on the horizontal axis and the annual immigration on the vertical axis. Note that Matplotlib plots the indices of a data frame on the horizontal axis, and with the data frame as shown, Matplotlib plots the countries on the horizontal axis. To fix this, we need to take the transpose of the data frame. Let's see how we can do this. After we sort our data frame in descending order of cumulative annual immigration, we create a new data frame of the top 5 countries, and we call it _top5. We then select only the columns representing the years 1980 to 2013 in order to exclude the total column before applying the transpose method. The resulting data frame is exactly what we want, with 5 columns where each column represents one of the top 5 countries and the years being the indices. Now we can go ahead and use the plot function on data frame df_top5 to generate the area plots. First, we import Matplotlib as MPL and its scripting interface as PLT. Then we call the plot function on the data frame df_top5, and we set kind equals area to generate an area plot. Then to complete the figure, we give it a title and label both the axes appropriately. Finally, we then use the show function to display the figure. Note that here we are generating the area plot using the inline backend. And there you have it, an area plot that depicts the immigration trend of the 5 countries with the highest immigration to Canada from 1980 to 2013. Area plots are particularly effective in depicting data with a cumulative nature, such as tracking stock market performance, visualizing population demographics, or displaying the distribution of resources across various sectors. In this video, you learned that an area plot depicts cumulated totals using numbers or percentages over time. The process of creating an area plot involves importing Matplotlib and calling the plot function on the data frame with kind parameter assigned as area. Area plots provide a visually appealing and intuitive way to showcase the relationship and proportion of multiple variables in a single chart. Welcome to Histograms. After watching this video, you'll be able to define a histogram with the help of an illustration, explore the process of creating a histogram using Matplotlib. Let's start by defining what a histogram is. A histogram is a way of representing the frequency distribution of a numeric dataset. The way it works is that it partitions the spread of the numeric data into bins, assigns each data point in the dataset to a bin, and then counts the number of data points assigned to each bin. So, the vertical axis is essentially the frequency or the number of data points in each bin. For example, let's say the range of the numeric values in the dataset is 34,129. Now, the first step in creating a histogram is partitioning the horizontal axis in, say, 10 bins of equal width. Then, we construct the histogram by counting how many data points have a value that is between the limits of the first bin, the second bin, the third bin, and so on. Say the number of data points that have a value between 0 and 3,413 is 175. Then we draw a bar of that height for this bin. We repeat the same step for all the other bins. And if no data points fall into a bin, then that bin would have a bar of height 0. So how do we create a histogram using Matplotlib? Let's process the data frame so that the country name becomes the index of each row. This should make retrieving rows pertaining to specific countries a lot easier. Also, let's add an extra column that represents the cumulative sum of annual immigration from each country from 1980 to 2013. So, for Afghanistan, it's 58,639 total, and for Albania, it's 15,699, and so on. And let's name our data frame DF_Canada. Considering the Canada immigration dataset, having countries as the index, and having another column as total represents the cumulative sum of annual immigration from each country from 1980 to 2013. Say we want to visualize the distribution of immigrants to Canada in the year 2013. The simplest way to do that is to generate a histogram of the data in column 2013. Let's see how we can do that with Matplotlib. First, we import Matplotlib as MPL and its scripting interface as PLT. Then we call the plot function on the data in column 2013 and we specify kind equals hist to generate a histogram. Then, to complete the figure, we give it a title and label both its axes. Finally, we use the show function to display the figure. And there you have it, a histogram that depicts the distribution of immigration to Canada in 2013. But notice how the bins are not aligned with the tick marks on the horizontal axis. This can make the histogram hard to read. So let's try to fix this in order to make our histogram more effective. One way to solve this issue is to borrow the histogram function from the NumPy library. So, as usual, we start by importing Matplotlib and its scripting interface, but this time we also import the NumPy library. Then we call the NumPy histogram function on the data in column 2013. This function is going to partition the spread of the data in column 2013 in 10 bins of equal width, where 10 is the default number of bins. It also computes the number of data points that fall in each bin and then return this frequency of each bin, which we are calling count here, and the bin edges, which we will call bin_edges. We then pass these bin edges as an additional parameter in our plot function to generate the histogram. And there you go, a precisely generated histogram with the bin edges and tick marks clearly aligned on the horizontal axis. In this video, you learned that a histogram is a way of representing the frequency distribution of a numeric dataset. To generate a histogram on Matplotlib, you import Matplotlib as MPL and its scripting interface as PLT. You can call the plot function on the data frame with kind parameter assigned as hist. You can use the NumPy library to create bins for the histogram representation. Welcome to bar charts. After watching this video, you'll be able to describe a bar chart with the help of an illustration. Explore the process of creating a bar chart using Matplotlib. A bar chart is a popular visualization tool. Unlike a histogram, a bar chart, also known as a bar graph, is a type of plot where the length of each bar is proportional to the value of the item that it represents. It's commonly used to compare the values of a variable at a given point in time. For example, say we want to visualize in a discrete fashion how immigration from Iceland to Canada looked from 1980 to 2013. One way to do that is by building a bar chart where the height of the bar represents the total immigration from Iceland to Canada in a particular year. How do we do that with Matplotlib? From our dataset on immigration to Canada, we created a data frame called DF_Canada, having country names as the index of each row, and a column total represents the cumulative sum of annual immigration from each country from 1980 to 2013. So let's see how we can use Matplotlib to generate a bar chart to visualize what immigration from Iceland to Canada looked like from 1980 to 2013. As usual, we start by importing Matplotlib and its scripting interface. Then we use the years variable to create a new data frame. Let's name it DF_Iceland, which includes the data pertaining to annual immigration from Iceland to Canada and excluding the total column. Then we use the plot function on DF_Iceland and we set kind equals bar to generate a bar chart. To complete the figure, we give it a title and label both of its axes. Finally, we use the show function to display the figure. And there you have it. A bar chart depicts immigration from Iceland to Canada from 1980 to 2013. By examining the bar chart, we notice that immigration to Canada from Iceland has seen an increasing trend since 2010. I'm sure the curious among you are already wondering who the culprit behind this increasing trend is. You can also create a bar chart with horizontal bars by assigning bar to the kind parameter of the plot function. Note the use of the color parameter, as you can change the color of the bar with this. Let's suppose you want to highlight the years with highest and lowest number of Icelandic immigrants to Canada between the year 1980 to 1990. You can pass a list of colors to the color parameter accordingly. Here we have highlighted the bars for the years 1981 and 1990 with the color red. By assigning the color of your choice to the edge color parameter, you can change the borderline color of each bar. In this video, you learned that a bar chart is a type of plot where the length of each bar is proportional to the value of the item that it represents. You can create a bar chart using Matplotlib representing the total immigration from Iceland to Canada. Welcome to pie charts. After watching this video, you'll be able to describe a pie chart with the help of an example. Explore the process of creating a pie chart using Matplotlib. So, what is a pie chart? A pie chart is a circular statistical graphic divided into segments to illustrate numerical proportion. For example, here is a pie chart of the Canadian federal election. It represents the party-wise percentage of seats won in the House of Commons. Next, let's learn how to create a pie chart with Matplotlib. Now, let's try to visualize the continent-wise breakdown of immigration to Canada from our dataset DF_Canada. The first step is to group the data by continent using the continent column, and we use pandas for this. We call the pandas group by function on DF_Canada, and we sum the number of immigrants from the countries that belong to the same continent. Here is the resulting data frame, and let's name it DF_continents. The resulting data frame has 6 rows, each representing a continent, and 35 columns representing the years from 1980 to 2013, plus the cumulative sum of immigration for each continent. Now, we're ready to start creating our pie chart. We start as usual by importing Matplotlib as MPL and its scripting layer, the pyplot interface, as PLT. Then we call the plot function on total column of the data frame df_continents, and we set kind equals pi to generate a pie chart. Then, to complete the figure, we give it a title. Finally, we use the show function to display the figure. And there you have it, a pie chart that depicts each continent's proportion of immigration to Canada from 1980 to 2013. The explode property of a pie chart in Matplotlib allows you to offset one or more slices from the center, highlighting specific sections of the chart. By assigning values to the explode parameter, you can control the degree of separation and emphasize particular segments of the pie. As shown in this pie, the continents where the total is less than 10% are exploded out to be highlighted. A final point about pie charts. There are some strong critics who oppose using pie charts in any condition. They argue that pie charts do not display accurate data consistently. When it comes to depicting data consistently and communicating the point, bar charts perform significantly better. If you're interested in learning about the arguments against pie charts, here's a link to a very interesting article that discusses very clearly the flaws of pie charts. You can also find the link under the video. In this video, you learned that a pie chart is a circular statistical graphic divided into segments to illustrate numerical proportion. The process of creating a pie chart involves importing Matplotlib to represent a large set of data over a period of time. Welcome to box plots. After watching this video, you'll be able to describe a box plot with the help of an illustration. Explain how to create box plots using Matplotlib. So, what is a box plot? A box plot is a way of statistically representing the distribution of given data through 5 primary dimensions. Minimum is usually the value obtained by subtracting 1.5 times the interquartile range, or IQR, from the first quartile. First quartile is the point 25% of the way through the sorted data. In other words, a quarter of the data points are less than this value. Median is the median of the sorted data. The third quartile is the point 75% of the way through the sorted data. In other words, 3/4 of the data points are less than this value. The maximum is usually the value obtained by adding the third quartile to 1.5 times the IQR. Finally, box plots also display outliers as individual dots outside the outer and lower extremes. Let's see how we can create a box plot with Matplotlib. We first process the data frame df_Canada to set the country name as the index and add a column representing the cumulative sum of annual immigration from each country from 1980 to 2013. We want to create a box plot to visualize immigration from Japan to Canada. As with the other tools we've learned, we start by importing Matplotlib as MPL and the pyplot interface as PLT. Then we create a new data frame in the data about Japan, and we exclude the total column using the years variable. Then we transpose the resulting data frame in the correct format to create the box plot. Let's name this new data frame df_Japan. Following that, we call the plot function on df_Japan and set a kind equals box to generate a box plot. Then we complete the figure. We give it a title and label the vertical axis appropriately. Finally, we use the show function to display the figure. And there you have it, a box plot that provides a good distribution of Japanese immigration to Canada from 1980 to 2013. From this plot, we can verify that there are no outliers in this data. Also, we can see that the median is closer to the top, indicating more data concentration in the upper half. In this video, you learned that a box plot is a way of statistically representing given data distribution through 5 main dimensions. The 5 main dimensions are minimum, first quartile, median, third quartile, and maximum. You can create a box plot using Matplotlib. Welcome to Scatterplots. After watching this video, you'll be able to describe what is a scatterplot with the help of an example. Explore the scatterplot creation process using Matplotlib. So, what is a scatterplot? A scatterplot is a type of plot that displays values pertaining to typically two variables against each other. Usually, it's a dependent variable that is plotted against an independent variable to determine if any correlation between the two variables exists. For example, here's a scatterplot of income versus education. And by looking at the plotted data, one can conclude that an individual with more years of education is likely to earn a higher income than an individual with fewer years of education. So, how can we create a scatterplot with Matplotlib? We are considering data frame DF_Canada, which has country names set as an index and one column as total, which represents the cumulative sum of annual immigration from each country from 1980 to 2013. Let's say we want to create a scatterplot of the total annual immigration to Canada from 1980 to 2013. To be able to do that, we first need to create a new data frame that shows each year and the corresponding total number of immigrants from all countries worldwide, as shown here. Let's name this new data frame as DF_total. Then we proceed as usual. We import Matplotlib as MPL and its scripting layer, the PyPlot interface, as PLT. We use the plot function on the data frame DF_total, and we set kind equals scatter to generate a scatterplot. Unlike the other data visualization tools, where only passing in the kind parameter was enough to generate the plot, with scatterplots, we also need to pass the variable, which is on the horizontal axis as the x parameter, and the variable that is on the vertical axis as the y parameter. In this case, we're passing column year as the x parameter and column total as the y parameter. Then, to complete the figure, we give it a title and label its axes appropriately. Finally, we use the show function to display the figure. And there you have it, a scatterplot that shows total immigration to Canada from countries all over the world from 1980 to 2013. The scatterplot clearly depicts an overall rising trend of immigration with time. Consider the use of the color parameter, which we have assigned a value of dark blue. You may like to pick a color of your choice from the available color palettes. For instance, see how the plot is in the color red. You can also use the S parameter to represent any third variable if you want to. Here we have included the total from the African continent to represent the size of each marker over the years, and it is evident that the number of immigrants has increased over these years as the size of the markers in the scatterplot is increasing. In this video, you learned that a scatterplot displays values pertaining to typically two variables against each other. The process of creating a scatterplot involves importing Matplotlib to visualize a large set of data. Welcome to Plotting Directly with Matplotlib. After watching this video, you'll be able to explore various functions offered by Matplotlib for data visualization and plotting. Differentiate between data storytelling and data visualization. Matplotlib is a general-purpose comprehensive plotting library that provides a flexible interface for creating a wide range of plots. Its PyPlot module offers a convenient way to create and customize plots quickly. Let's start plotting directly with Matplotlib. First, we need to import the library. Import matplotlib.pyplot as PLT. Here we're importing pyplot as PLT. We have also imported NumPy as NP, as NumPy arrays are usually used as a data source for plotting and also support mathematical functions. Next, for tabular data, import pandas. Then call the subplot function and create a figure, the canvas window, and the axes. It's the area where the plot appears. The figure axes pair provides greater control over the figure or canvas. Now name the plot that you want to create on these axes. Let's now call plot function on the axes to display the line plot. We'll create some synthetic data to generate the plot using NumPy. Years is equal to np.arange and passing 1980. 2014 to arange function will generate a 1D array of numbers from 1980 to 2013, excluding 2014. Immigrants equals np.random.randant will generate a 1D array of random integers between 2,000 to 10,000 range. Size equals 34 specifies the number of elements in the array. Ax.plot function will create a line plot. It takes the x and y values as arguments corresponding to the data to be considered for the x-axis and the y-axis. Ax.plot, years, immigrants. Finally, display the plot using plt.show function. And if you want to display this data as a scatter plot, call the scatter function on Ax instead, as shown here. Ax.scatter and pass years and immigrants to it. Now let's put a title to the plots. To do so, simply pass the title string to the plt.title function. plt.title immigrants between 1980 to 2013 on both the plots. Label the axis with plt.xlabel as years and plt.ylabel as total immigrants on both axes. You can apply the label and title directly to the axes as shown here. Axes.set_title and pass the title string. Axes.set_xlabel or ylabel. See now, the plots have the title and the labels. Now, using xlim and ylim functions, you can set the limits on the x and y axis. To improve the readability, you can enable grid lines with grid function and pass it with true, like ax.grid, true. Legend function will include the legend to your plot. Notice that the x-axis now starts with 1975 and ends with 2015, and now it shows the grid at the background of the plot. There are various options available to customize the plot. You can customize the plot with line styles, marker styles, and color customization options to achieve the desired visual effects. With marker, select a style to represent data points in your plot, like S for square and O for dots. For line plot, the marker is marker size, while in scatter, it's just S. Similarly, you select a color and a size for it. With the line style parameter, you can select different line styles, such as solid, dashed, or dotted lines. Notice the use of LOC in the legend parameter to specify the location where the legend is placed on the figure. Let's now use a bar plot to represent the number of immigrants for each year. Ax.bar function creates a bar plot, passing years corresponding to the x-axis and the immigrants to the y-axis. The height of each bar represents the number of immigrants for that year. Ax.hist generates a histogram with bins set to 20. Notice the use of edge color and color parameters to specify the border and bar column of the histogram. Ax.pie will generate a pie on the axes. Here we're plotting a pie for only 5 years, 1980 to 1984. Colors are assigned to each pie slice as a list of colors, and labels are set as years. AutoPCT displays the percentage of immigrants with 1 decimal point. Now let's explore how to display more than one plot on the same figure and specify the number of rows and columns to be created to the subplots function. For instance, let's create a line and scatter plot in one row, plt.subplots, and pass 1, 2 to it. Both the subplots will be sharing the same y-axis, as the data in the y-axis is the same, so assign the Sherry parameter as true. Now you have two axes, axs with index 0 and axs with index 1, and you can plot your plots as you did earlier. Axs0.plot function for the line, axs1.scatter for a scatter plot. And see, you have created two plots together. Alternatively, we can use the add_subplot function. It takes 3 arguments. First, the number of rows. Second, columns. And the last is an index of the subplot. You can create different axes on the figure and add subplots as shown here. Ax 1 equals figure.add_subplot 2, 2, 1. This one means the first axes on the 2 by 2 divided figure. Then, on these axes, create the plot like an ax1.plot. Similarly, you can plot all the plots you want on the 4 axes. Like this, you have all your plots on this figure. Great work! Lastly, let's learn about data storytelling and data visualization. These are 2 different terms and serve different purposes. Data storytelling is the art of storytelling that involves creating a narrative around the data. It presents a compelling and engaging story. On the other hand, data visualization is an important aspect of data storytelling and involves creating informative charts to understand and explore patterns, trends, and relationships within the data. It brings data to life. We recommend reading this article titled Data Storytelling, the Essential Data Science Skill Everyone Needs, on www.forbes.com for more on data storytelling. In this video, you learned that Matplotlib is a versatile plotting library that offers a flexible interface for creating various types of plots. Matplotlib's PyPlot module offers a convenient way to create and customize plots quickly. Data storytelling is the art of storytelling that involves creating a narrative around the data. Data visualization is an important aspect of data storytelling and involves creating engaging visuals. Welcome to Plotting Directly with Matplotlib. After watching this video, you'll be able to explore various functions offered by Matplotlib for data visualization and plotting, differentiate between data storytelling and data visualization. Matplotlib is a general-purpose comprehensive plotting library that provides a flexible interface for creating a wide range of plots. Its PyPlot module offers a convenient way to create and customize plots quickly. Let's start plotting directly with Matplotlib. First, we need to import the library. Import matplotlib.pyplot as PLT. Here we're importing pyplot as PLT. We have also imported NumPy as NP, as NumPy arrays are usually used as a data source for plotting and also support mathematical functions. Next, for tabular data, import pandas. Then call the subplot function and create a figure, the canvas window, and the axes. It's the area where the plot appears. The figure-axes pair provides greater control over the figure or canvas. Now name the plot that you want to create on these axes. Let's now call plot function on the axes to display the line plot. We'll create some synthetic data to generate the plot using NumPy. Years is equal to np.arange and passing 1980. 2014 to arange function will generate a 1D array of numbers from 1980 to 2013, excluding 2014. Immigrants equals np.random.randant will generate a 1D array of random integers between 2,000 to 10,000 range. Size equals 34 specifies the number of elements in the array. Ax.plot function will create a line plot. It takes the x and y values as arguments corresponding to the data to be considered for the x-axis and the y-axis. Ax.plot, years, immigrants. Finally, display the plot using plt.show function. And if you want to display this data as a scatter plot, call the scatter function on Ax instead, as shown here. Ax.scatter and pass years and immigrants to it. Now let's put a title to the plots. To do so, simply pass the title string to the plt.title function. plt.title immigrants between 1980 to 2013 on both the plots. Label the axis with plt.x label as years and plt.y label as total immigrants on both axes. You can apply the label and title directly to the axes as shown here. axes.set_title and pass the title string. axes.set_x label or y label. See, now the plots have the title and the labels. Now, using xlim and ylim functions, you can set the limits on the x and y axis. To improve the readability, you can enable grid lines with grid function and pass it with true, like ax.grid, true. Legend function will include the legend to your plot. Notice that the x-axis now starts with 1975 and ends with 2015, and now it shows the grid at the background of the plot. There are various options available to customize the plot. You can customize the plot with line styles, marker styles, and color customization options to achieve the desired visual effects. With marker, select a style to represent data points in your plot, like S for square and O for dots. For line plot, the marker is marker size, while in scatter, it's just S. Similarly, you select a color and a size for it. With the line style parameter, you can select different line styles, such as solid, dashed, or dotted lines. Notice the use of LOC in the legend parameter to specify the location where the legend is placed on the figure. Let's now use a bar plot to represent the number of immigrants for each year. ax.bar function creates a bar plot, passing years corresponding to the x-axis and the immigrants to the y-axis. The height of each bar represents the number of immigrants for that year. ax.hist generates a histogram with bins set to 20. Notice the use of edge color and color parameters to specify the border and bar column of the histogram. ax.pi will generate a pi on the axes. Here we're plotting a pi for only 5 years, 1980 to 1984. Colors are assigned to each pie slice as a list of colors, and labels are set as years. AutoPCT displays the percentage of immigrants with 1 decimal point. Now let's explore how to display more than one plot on the same figure and specify the number of rows and columns to be created to the subplots function. For instance, let's create a line and scatter plot in one row, plt.subplots, and pass 1, 2 to it. Both the subplots will be sharing the same y-axis, as the data in the y-axis is the same, so assign the Sherry parameter as true. Now you have two axes, axs with index 0 and axs with index 1, and you can plot your plots as you did earlier. axs0.plot function for the line, axs1.scatter for a scatter plot. And see, you have created two plots together. Alternatively, we can use the add_subplot function. It takes 3 arguments. First, the number of rows. Second, columns. And the last is an index of the subplot. You can create different axes on the figure and add subplots as shown here. ax1 equals figure.add_subplot 2, 2, 1. This one means the first axes on the 2 by 2 divided figure. Then, on these axes, create the plot like an ax1.plot. Similarly, you can plot all the plots you want on the 4 axes. Like this, you have all your plots on this figure. Great work! Lastly, let's learn about data storytelling and data visualization. These are 2 different terms and serve different purposes. Data storytelling is the art of storytelling that involves creating a narrative around the data. It presents a compelling and engaging story. On the other hand, data visualization is an important aspect of data storytelling and involves creating informative charts to understand and explore patterns, trends, and relationships within the data. It brings data to life. We recommend reading this article titled Data Storytelling, the Essential Data Science Skill Everyone Needs, on www.forbes.com for more on data storytelling. In this video, you learned that Matplotlib is a versatile plotting library that offers a flexible interface for creating various types of plots. Matplotlib's PyPlot module offers a convenient way to create and customize plots quickly. Data storytelling is the art of storytelling that involves creating a narrative around the data. Data visualization is an important aspect of data storytelling and involves creating engaging visuals. Welcome to Seabor and regression plots. After watching this video, you'll be able to explain what Seabor is and what it does. Describe the functions of Seabor. Although Seabor is another data visualization library, it's based on Matplotlib. Seabor offers a range of built-in themes and color palettes that improve the visual appeal of your plots with minimal effort. Seabor makes creating plots very efficient. Therefore, with Seabor, you can generate plots with code that is 5 times less than with Matplotlib. Seabor integrates well with statistical libraries such as NumPy and SciPy, allowing you to easily combine statistical analysis with visualizations. It provides specialized plot types such as regression plots, distribution plots, and categorical plots that are particularly useful for analyzing data and modeling relationships. While Pandas and Matplotlib are powerful tools for data manipulation and basic visualization, Seabor complements them by providing a higher-level interface for creating visually appealing and informative statistical graphics. Seabor works well, especially when dealing with more complex visualizations and statistical analyses. Let's see how we can use Seabor to create a statistical graphic. Let's look into regression plots. Let's say we have a data frame called DF_total, representing total immigration to Canada from 1980 to 2013. The data frame displays the year in one column and the corresponding total immigration in another. We want to create a scatter plot and a regression line to highlight any trends in the data. With Seabor, you can do all this with one line of code. We first import Seabor, and let's import it as SNS. Then we call the Seabor regplot function. We tell it to use the data frame DF_total and to plot the column year on the horizontal axis and the column total on the vertical axis. The output of this one line of code is a scatter plot with a regression line, and not just that, but also a 95% confidence interval. Seabor's regplot function also accepts additional parameters for any personal customization. So, you can change the color, for example, using the color parameter. Let's go ahead and change the color to green. Also, you can change the marker shape as well, using the marker parameter. Let's go ahead and change the shape of our markers to a plus marker instead of the default circular marker. Let's try to plot some categorical data. In our Canada Immigration Dataset, there are some categorical features such as country, region, and continent. Why not plot continents for their count in the dataset? Using a single line of code, we can create a bar plot representing the count of records for each continent in the data using the counterplot function. The X parameter specifies the categorical variable to be plotted on the X-axis, the country, and the data parameter sets the dataset to be used DF_Canada. Though we haven't used all observations from the dataset, it's evident from the plot that most of the observations in the data are from Africa. Let's try to plot the Bohr plot on the categorical data from a slice of the DF_Canada dataset. Here we have plotted the continent by the total column of data. Seabor has been grouped by the categorical variable continent and plotted the aggregated values of total with confidence interval. You'll explore more in the lab session on Seabor. In this video, you learned that Seabor is a data visualization library based on Matplotlib. Seabor was built primarily to provide a high-level interface for drawing statistical graphics. Scatter plots and regression lines can be created with one line of code using Seabor. Seabor's regplot function accepts additional parameters for personal customization. Welcome to an introduction to Folium. After watching this video, you'll be able to describe Folium and its features, explain what Folium is used for. Folium is a powerful data visualization library in Python that was built primarily to help people visualize geospatial data. With Folium, you can create a map of any location in the world using latitude and longitude values. You can also create a map and superimpose markers and clusters on top of the map for interesting visualizations. You can also create maps of different styles, such as street-level maps, stamen maps, and a couple of others which we will look into in just a moment. Creating a world map with Folium is straightforward. First, you need to import Folium, and then you call the map function, and that is all. What's interesting about the maps created by Folium is that they are interactive, so you can zoom in and out after the map is rendered, which is a helpful feature. The default map style is OpenStreetMap, which shows a straight view of an area when you are zoomed in and shows the borders of the world countries when you are zoomed out all the way. Now, let's create a world map centered around Canada. To do that, we pass in Canada's latitude and longitude values using the location parameter. With Folium, you can set the initial zoom level using the zoom_start parameter. Use initial because you can easily change the zoom level after the map is rendered by zooming in or out. You can play with this parameter to determine the initial zoom level for different values. Let's set the zoom level for our map of Canada to 4. The result will be a world map centered around Canada. Another feature of Folium is that you can create different map styles using the tiles parameter. Let's create a stamen toner map of Canada. This style is great for visualizing and exploring river meanders and coastal zones. Another style is stamen terrain. Let's create a map of Canada in stamen terrain. This style is excellent for visualizing hill shading and natural vegetation colors. In this video, you learned that Folium is a data visualization library in Python that helps people visualize geospatial data. With Folium, you can create maps of different styles, such as street-level maps, stamen maps, and more. A feature of Folium is that you can create different map styles using the tiles parameter. Welcome to Maps with Markers. After watching this video, you'll be able to explain how Folium can add markers to a map. Describe how to generate markers. With Folium, you can easily add markers on the map. Let's first render a world map centered around Canada. First, import Folium, then create the map object. Remember that the location parameter specifies the latitude and longitude coordinates of the center point of the map. The zoom_start sets the initial zoom level of the map. In this case, zoom_start equals 4 provides a zoomed-out view of Canada. You can display it by simply calling Canada_map. Markers play a vital role in enhancing interactivity and adding context to maps. They represent specific locations or points of interest, providing additional information when clicked. Markers are like signposts that guide us through the map, highlighting important elements. Ontario is a Canadian province that contains about 40% of the Canadian population. It is considered Canada's most populous province. Let's add a marker for Ontario Province, one of the largest provinces in Canada, to our map. Using the folium.marker function, we specify the location parameter as 51.2538, 85.3232, representing the approximate coordinates for Ontario. Additionally, we set the pop-up parameter as Ontario to provide a label when the marker is clicked. The add_to Canada_map method is called on the Folium.marker object to add the marker for Ontario to the Canada_map. This ensures that the marker is included as part of the map's layers and will be displayed when the Canada_map is rendered or saved. Alternatively, we can create the marker using feature group. Let's go ahead and create a feature group named Ontario. Now, when a feature group is created, it is empty. So what's next is to start creating what is called children and adding them to the feature group. So let's create a child in the form of a red circular mark located at the center of the Ontario province. We specify the location of the child by passing in its latitude and longitude values. And once we're done adding children to the feature group, we add the feature group to the map. The result is a red circular mark superimposed on top of the map and added to the center of the province of Ontario. Now, it would be helpful if we could label this marker in order to let other people know what it represents. To do that, we use the marker function and the pop-up parameter to pass in the text we want to add to this marker. The result is our marker displays Ontario when clicked on. In the lab session, we will view a real-world example and explore the crime rate in San Francisco. We'll create a map of San Francisco and superimpose thousands of these markers on top of the map. Also, how you can generate marker clusters to make your map look less congested. This module's lab session is interesting, so ensure you complete it. Displaying multiple markers on a map is essential when using larger maps. Suppose you want to show multiple markers on the map. How can you do that? It's simple. Create a list of all the locations. Then pass this list to the marker function, adding an underscore to function through a loop. And your map with multiple markers will be ready for display. When creating code to display multiple markers on a map, you can call the mark cluster object, add an underscore to the function, and pass your map here. It's the same as creating a list of locations. Then, pass this list to the marker function through the loop. But this time, instead of map, use master_cluster to add the underscore to functions, and your map with multiple markers will be displayed. The markers within the marker_cluster will be intelligently grouped based on their proximity when the map is displayed. This clustering feature enhances the visual presentation by preventing overcrowding and ensuring a clear representation, primarily when numerous markers are close. In this video, you learned that with Folium, you can easily add markers on maps. The location parameter specifies the latitude and longitude coordinates of the center point of the map. Markers play a vital role in enhancing interactivity and adding context to maps. The Folium.marker function specifies location parameters. The pop-up parameter provides a label upon being clicked. Markers can be created using feature group. Welcome to Choropleth Maps. After watching this video, you'll be able to describe Choropleth Maps, explain what are the uses for Choropleth Maps. Most of you have seen maps like this. These are what we call Choropleth Maps. So, what is a Choropleth Map? A Choropleth map is a thematic map in which areas are shaded or patterned in proportion to the measurement of the statistical variable displayed on the map, such as population density or per capita income. The higher the measurement, the darker the color. So the map to the left is a Choropleth world map showing the infant mortality rate per 1,000 births. The darker the color, the higher the infant mortality rate. According to the map, African countries have very high infant mortality rates, with some reporting a rate higher than 160 per 1,000 births. Similarly, the map on the right is a Choropleth map of the U.S., showing population per square mile by state. Again, the darker the color, the higher the population. According to the map, states in the eastern part of the U.S. tend to be more populous than states in the western part, with California being an exception. Folium is a Python library used for creating interactive maps and visualizations. It provides a simple and intuitive way to generate maps using data from various sources, including GeoJSON, Pandas data frames, and NumPy arrays. To create a Choropleth map of a region of interest, Folium requires a GeoJSON file that includes geospatial data of the region. For a Choropleth map of the world, we would need a GeoJSON file that lists each country and any geospatial data to define its borders and boundaries. Here's an example of what a GeoJSON file would include about each country. The example here pertains to the country Brunei. As you can see, the file consists of its name, ID, geometry shape, and coordinates that define its borders and boundaries. So let's see how we can create a Choropleth map of the world showing immigration to Canada. Before creating the map's code, let's quickly recap our dataset. Recall that each row represents a country and contains metadata about it, such as where it is located geographically and whether it's developing or developed. Each row also contains numerical figures for annual immigration from that country to Canada from 1980 to 2013. And let's name our data frame df_Canada. So now that we know our data is stored in the data frame df_Canada, let's see how we can generate a Choropleth map of the world showing immigration to Canada. We should be experts now in creating world maps with Folium, so let's go ahead and create a world map, but this time let's use the Matplotlib tile set. The result is a nice world map displaying the name of every country. Now let's convert this map into a Choropleth map. We first define a variable that points to our JSON file. Then we apply the Choropleth function to our world map. We tell it to use the country, total columns in our df_Canada data frame, and the country names to look up the geospatial information about each country in the GeoJSON file. The result will be a Choropleth map of Canada showing the intensity of immigration from different countries worldwide. We explore Choropleth maps in more detail in the lab session, so be sure to complete this module's lab session. In this video, you learned that a Choropleth map is a thematic map in which areas are shaded or patterned in proportion to the measurement of the statistical variable. When creating a Choropleth map, Folium requires a GeoJSON file that includes geospatial data of the region. The Mapbox Bright tile set displays the name of every country when used on a map. Welcome to Dashboarding Overview. After watching this video, you'll be able to explore the benefits of using interactive data applications to improve business performance, identify different web-based dashboarding tools available in Python. With real-time visuals on the dashboard, understanding business moving parts becomes easy. Based on the report type and data, suitable graphs and charts can be created in one central location. This provides an easy way for stakeholders to understand what is going right or wrong and what improvements are necessary. Also, getting the big picture in one place can help businesses make informed decisions, which can improve performance. In general, the best dashboards answer critical business questions. Let's say you're assigned a task to monitor and report the performance of domestic U.S. flights. Following are the yearly review report items. Top 10 airline carriers in the year 2019 in terms of the number of flights. Number of flights in 2019 split by month. Number of travelers from California State to other states split by distance group. Let's look at two ways of presenting the report. Type 1. The report is presented through tables, with inference from tables documented for reference. Type 2. Here, we are presenting the same report in the dashboard format. As you can see, hovering over each chart will provide details about the data points. At the bottom, in the sunburst chart, you can click on different numbers, drill down into levels, and get detailed information about each segment. Can you observe the difference in the presentation of the findings? What if we need to get the report on real-time data, not static data? Also, presenting the result using tables and documents is time-consuming, less visually appealing, and hard to comprehend. A data scientist should have the ability to create and deliver a story around the finding in a way stakeholders can easily understand. With that in mind, dashboards are the way to go. Let's take a look at web-based dashboarding tool options available in Python. Dash is a Python framework for building web analytic applications. It runs on top of Flask, Plotly.js, and React.js. Dash is well suited for building data visualization apps with highly customized user interfaces. Panel works with visualizations from Bokeh, Matplotlib, HoloViews, and many other Pylon plotting libraries, making them instantly viewable either individually or when combined with interactive widgets that control them. Panel works equally well in Jupyter notebooks for creating quick data exploration tools or as a standalone deployed apps and dashboards and allows you to easily switch between those contexts as needed. Voila turns Jupyter notebooks into standalone web applications. It's compatible with separate layout tools like Jupyter Flex or templates like Voila Viewtify. Streamlit can easily turn data scripts into shareable web apps with three main principles: embrace Python scripting, treat widgets as variables, and reuse data and computation. There are other tools that can be used for dashboarding. Bokeh is a plotting library, widget, and app library. It acts as a server for both plots and dashboards. Panel, which is one of the web-based dashboarding tools, is built on Bokeh. IPyWidgets provides a wide array of Jupyter-compatible widgets and an interface supported by many Python libraries, but sharing as a dashboard requires a separate deployable server like Voila. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. Bowtie allows users to build dashboards in pure Python. Flask is a Python-backed web server that builds arbitrary websites, including those with Python plots that then function as Flask dashboards. In this video, you learned that Dashboard simplifies the dynamic aspect of the business. Data can be presented by using different types of dashboards. There are different types of dashboarding tools. Welcome to Introduction to Plotly. After watching this video, you'll be able to explore Plotly and its two submodules, discover how to use Plotly graph objects and Plotly Express to create customized and interactive charts. So, what is Plotly? Plotly is an interactive open-source plotting library that supports over 40 unique chart types. It's available in Python, R, and JavaScript. Plotly Python is an extension of Plotly JavaScript library and includes chart types like statistical, financial, maps, scientific, and three-dimensional data. The web-based visualizations created using Plotly Python can be displayed in Jupyter Notebook, saved to standalone HTML files, or served as part of pure Python-built web applications using Dash. Here, we'll be focusing on the two submodules of Plotly, Plotly Graph Objects and Plotly Express. Plotly Graph Objects is the low-level interface to figures, traces, and layout. The Plotly Graph Objects module provides an automatically generated hierarchy of classes, figures, traces, and layout, called graph objects that are used for representing figures with a top-level class plotly.graph_objects.figure. Plotly Express is a high-level wrapper for Plotly. It's a recommended starting point for creating the most common figures provided by Plotly because of its simple syntax. It uses graph objects internally. Let's see how to use Plotly.graph_objects submodule with a simple line chart creation example. First, import the required packages. Here, we're importing graph objects as Go. By writing the code, import Plotly.graph_objects as Go. Then, we're importing Plotly Express with import Plotly.express as px command. Lastly, we need NumPy to generate sample data. so we're importing NumPy. Import NumPy as NP. Then generate sample data. With np.random.seed10, we're setting random seed for reproducibility. Now let's create an array of 12 elements. X equals np.arrange, 12. Let's create random y values by using random module y equals np.random.randant, 50, 500, size equals 12. The Plotly.graph contains a JSON object, which has a dictionary structure. Since we imported Plotly graph object as Go in the previous slide, Go will be the JSON object. The chart can be plotted by updating the values of the Go object keywords. We create the figure by adding a trace, which is called scatter, here. Let's view the code. Fig equals go.figure. Data equals go.scatter. X equals X, Y equals Y. Next, the layout of the figure is updated using the update layout method. Here, we are updating the x-axis, y-axis, and chart title. Let us view the code. Fig.update_layout. Title equals simple line plot. X-axis underscore title equals month. Y-axis underscore title equals sales. Then, Fig.show method is called to display the created plot. This is the plotted figure. Now we will create the same line chart using Plotly Express. As you can see in the example, the entire line chart can be created using a single command. Let's view the code. Hashtag entire line chart can be created in a single command. Fig equals px.line, x equals x, y equals y, title equals simple line plot, labels equals dict, x equals month, y equals sales, fig.show. Visualization is automatically interactive. Plotly Express makes visualization easy to create and modify. It's time to play with the Plotly library. We'll use the airline reporting data set from the Data Asset Exchange to demonstrate how to use Plotly graph objects and Express to create charts. Here's a quick overview of the airline reporting data set. The reporting carrier on-time performance data set contains information on approximately 200 million domestic U.S. flights reported to the United States Bureau of Transportation Statistics. The dataset contains basic information about each flight, such as date, time, departure airport, and arrival airport, and, if applicable, the length of time the flight was delayed and information about the reason for the delay. In this video, you learned that Plotly is an interactive, open-source plotting library that supports over 40 unique chart types. Plotly Graph Objects is the low-level interface to figures, traces, and layout. Plotly Express is a high-level wrapper for Plotly. It uses graph objects internally. Welcome to Introduction to Dash. After watching this video, you'll be able to explain what Dash is and its uses. Describe what Dash HTML components are. Dash is an open-source, user interface Python library for creating reactive, web-based applications. It's both enterprise-ready and a first-class member of Plotly's open-source tools. Dash applications are web servers running Flask and communicating JSON packets over HTTP requests. Dash's front end renders components using React.js. It's easy to build graphical user interfaces using Dash as it abstracts all technologies required to make the applications. Dash is declarative and reactive. It can be rendered in a web browser and deployed to servers. It provides a simple, reactive decorator for binding code to UI. They are inherently mobile and cross-platform ready. Let's say you plan to create an application to answer business questions. As a first step, you need to determine the application's layout. Decide which chart to use and where to place it, for example. This is called the layout part of Dash. The second part is to add interactivity to the application. There are two components of Dash. First is the core components. We can import the core components as DCC using this import statement. Next is HTML components. We can import HTML components as HTML using this import statement. Let's see them one by one. The --core_components describe higher-level interactive components generated with JavaScript, HTML, and CSS through the React.js library. Some examples of core components are creating a slider, input area, check items, and date picker. You can explore other components using the reference link at the slide's end. The --HTML_components library has a component for every HTML tag. You can compose your layout using Python structures with the --HTML-components library. The --HTML_components library provides classes for all HTML tags, and the keyword arguments describe the HTML attributes like style, class name, and ID. No knowledge of HTML or CSS is required, but it can help style the dashboards. In this video, you learned that Dash is an open-source user interface Python library for creating reactive, web-based applications. It's easy to build graphical user interfaces using Dash as it abstracts all technologies required to make the applications. There are two components of Dash, core and HTML components. The --core_components describe higher-level interactive components generated with JavaScript, HTML, and CSS through the React.js library. The --HTML_components library has a component for every HTML tag. Welcome to Make Dashboards Interactive. After watching this video, you'll be able to describe the callback function, determine how to connect core and HTML components using callbacks. Let's understand how to connect core and HTML components using callbacks. A callback function is a Python function that is automatically called by Dash whenever an input component's property changes. Callback function is decorated with @app.callback decorator. So what does this decorator tell Dash? Basically, whenever there's a change in the input component value, the callback function wrapped by the decorator is called, followed by the update to the output component children in the application layout. Let's look at the callback function skeleton. First, create a function that will perform operations to return the desired result for the output component. Decorate the callback function with @app.callback decorator. This takes two parameters. 1. Output. This sets results returned from the callback function to a component ID. 2. Input. This set input is provided to the callback function to a component ID. From here, we connect input and output to a desired property. We will see this in action with an example using the airline data. Use the case here to extract the top 10 airline carriers in the provided input year in terms of the number of flights. Based on the input year, the output will change. First, we import the required packages. As seen before, we'll import pandas, dash core, and HTML components. The new entry here is dash dependencies. From dash dependencies, we're importing input and output that we will use in the callback function. We read the airline data into the pandas data frame. We load our data frame at the start of the app, and it can be read inside the callback function. We will start designing the Dash application layout by adding components. First, we'll provide the title to the Dash app using the HTML heading component h1 and style it using the style parameter. Next, we're adding an HTML division and text input core component. In dash The inputs and outputs of the application are simply the properties of a particular component. In this example, our input is the value property of the component that has the ID input-YR. By default, the value has 2010. We will update this value in our callback function. Lastly, we will add a division with a graph core component. The core component has bar-plot as ID, which we will update inside the callback function. Note the component IDs. We will add a callback decorator, app.callback. Input to the callback will be the component with ID input-YR and property value. Output to the callback will be the component ID bar-plot and property figure. Component underscore ID and component underscore property keywords are optional and provide clarity. Next, we will define the callback function get underscore graph. The entered year will be the input. Using the year, we extract the required information from data and the application layout graph updates. Lastly, we will run the application. This is the output of the code. Our initial input year is 2010. As the year is updated, the graph is getting updated in parallel. The second example is a callback with two inputs. It's similar to one input callback except for a few changes. We will add a division with one more text input with the component ID input-AB. Then add the new input with component ID input-AB to the decorator inside a list. Next, we'll define callback function get underscore graph. This takes the entered year and the entered state as input parameters. Computation extracts the information and the application layout updates with the graph. This is the output of the code. Our initial input year is 2010 and the state is AL, which is Alabama. As the year and state update, you'll observe that the graph gets updated in parallel. In this video, you learned that a callback function is a Python function that is automatically called by dash whenever an input component's property changes. The @app.callback decorator decorates the callback function in order to tell dash to call it whenever there's a change in the input component value. The callback function takes input and output components as parameters and performs operations to return the desired result for the output component. Welcome to Walk Through the Flight Delay Time Statistics Dashboard Lab. After watching this video, you'll be able to describe the Skills Network Labs Cloud IDE environment, analyze flight on-time data by creating line graphs with dashboard components, create the layout of the Dash application, list the steps to run and launch the application. We'll be using the Skills Network Labs, SN Labs, Cloud IDE environment for this activity. Skills Network Labs Cloud IDE provides a hands-on environment in your web browser for completing course and project-related labs. It utilizes Theia, an open-source IDE platform that can run on a desktop or the cloud. When you open the lab, the screen will have two sides. On the left side, you'll see the lab's instructions. On the right side is the Integrated Development Environment, IDE, where you'll complete the following: use terminal, write code, and so on. Let's have a closer look at this IDE window. At the top, there is a core menu that comprises of submenus to help you create new files, save, run, and debug a terminal submenu, and so on. On the left side is a project-specific menu where you can find options to launch your application. To open a new terminal, click the terminal in the core menu and then click New Terminal. Here we have completed it. Great! Let's start with the lab. We will work on the airline reporting carrier on time. The performance data set, sourced from the Data Asset Exchange, encompasses details on nearly 200 million domestic U.S. flights reported to the United States Bureau of Transportation Statistics. It includes essential details about each flight, such as the time, date, departure airport, arrival airport, duration of flight delay, and information pertaining to the cause of the delay. You will analyze flight delays in a dashboard. You'll be creating 5-line graphs with dashboard components for monthly average carrier delay, monthly average weather delay, monthly average national air system delay, monthly average security delay, monthly average late aircraft delay by reporting airline for the given year. 1. In the terminal, install all the required packages as mentioned in the instructions. Copy the pip commands. 2. Paste it into the terminal and then press Shift plus Enter to execute them. Do this for all 3 pip commands one by one. It will take a while. Let's now create a new script file to write the code. 1. Click File in the core menu bar and then click New File. 2. A pop-out prompt will appear on the screen. Here, mention the name of this file as indicated in the instructions, flight_delay.py, and click OK. 3. Here it is. The file is ready and open in the IDE. First, we need to import the libraries and pull the dataset into the script file. 1. The instructions side of the screen mentions all the required libraries. Additionally, the code mentioned to fetch the dataset with pandas is airline_data equals pd.read_CSV. 2. Copy and paste them into the script file. 3. As shown here. Now it's time to design the layout of the app. 1. We will first create the Dash app by calling the Dash function app equals dash.dash function. 2. To add a layout division using HTML, you can utilize the dcc.input_function tag inside the layout division along with the div function and input components. 3. Using the display as flex for 2 outer divisions to get graphs side by side in a row. 4. Write or copy the code from the instructions and paste it into the script file below the previous code. Now that we have the skeleton, let's include the components. 1. The title will go in the html.h1 function as a string, and you can style the text. 2. Inside the first HTML division, which we refer to as the dcc.input tag, the input component can be customized with various attributes. For instance, you can assign the ID as input year, set the value as 2010, specify the type as number, and even customize the style attributes such as height and font size. 1. When utilizing the style parameter, you can actively add different graphs to the divisions. We assign display as flex to place 2 plots side by side in a row. Use dcc.graphTag for including the plot and give each plot an ID. For the year input by user, we need to compute the airline data and make charts and plots. 1. Let's call this function compute_info. Pass the dataset and the input year as arguments. The function should return all the average delays for that year. 2. Within this function, we will aggregate the specific delay by grouping the dataset for the month and the reporting airline's features. You can compute all the delays as individual plots, but best practice would be to create a function. As we need our dashboard to update in real time based on the year value input by the user, we will now create a callback function. First, we will create a callback decorator. 1. Update the output component ID parameter with the IDs provided in the dcc.graph function component for all 5 components we created and set the component property as a figure, like this. 2. And then update the input component ID parameter with the ID and set the property as value. 3. Then create a callback function that uses the input provided to perform the computation. 4. Create a graph in this function and return it as an output. 5. Lastly, call the run.server function on the app. 6. Good work! 7. To run this application, use the command python3 flight_delay.py in the terminal. 1. You will get the port number after you run the application. 2. Now you need to launch it. Click the Skills Network toolbox. 3. Then click the Launch application. 4. Enter the port number, in this case 8050, in the application port box. 5. And then click Your Application. 6. The output should look like this. In this video, we have walked through the lab where you developed a dashboard with Dash Framework on flight delay time statistics.